Download this code from codegive.com, link in the description below. Certainly. Spectral freezing is a fascinating technique that involves capturing a snapshot of the spectral content of an audio signal and holding it for a duration, often used in sound design and music production. In Max/MSP, this can be achieved using various objects that manipulate audio signals in the frequency domain. Tutorial: Spectral freeze in Max/MSP. Overview. In this tutorial, we will create a simple spectral freeze effect using Max/MSP. We will analyze an incoming audio signal, store its spectral data, and then allow the user to freeze and unfreeze the sound. Requirements: Max/MSP, any recent version. Key objects: ifft, performs a fast Fourier transform on an audio signal. ifft, inverse fast Fourier transform to convert back to the time domain. Buffer, a buffer to hold the spectral data. Snapshot, to take a snapshot of the current audio signal. Toggle, to control the freeze and unfreeze functionality. Step-by-step instructions. 1. Create a new patch, open Max/MSP and create a new patch. 2. Add audio input, use the ADC object to receive audio input. It will serve as the source for our spectral freeze. 3. FFT processing, create an FFT object to perform the FFT on the incoming audio signal. 4. Buffer for spectral data, create a buffer object to store the spectral data. Name it something like spectral buffer. 5. Snapshot of spectral data, use snapshot to capture the spectral data. You can add a toggle to control when to freeze the audio. 6. Store spectral data, connect the output of the snapshot to a peak object to store the spectral data in the buffer when the toggle is on. 7. Inverse FFT, after capturing the spectral data, route it to ifft to convert it back into the time domain. 8. Audio output, finally, connect the output of the ifft object to the DAC for playback. Example code. Here's how the complete Max patch might look in code form. Instructions for use. Load the above patch into Max/MSP. Connect an audio input to the ADC object. Use the toggle to freeze and unfreeze the spectral content. When frozen, the sound will hold the last captured spectral snapshot. Additional tips. Experiment with different buffer sizes for finer or coarser frequency resolution. Try manipulating the spectral data before sending it to ifft to create interesting effects. Consider adding a GUI for controlling parameters dynamically. Conclusion. This tutorial provides a basic framework for implementing a spectral freeze effect in Max/MSP. You can expand upon this by adding more features, such as modulation effects or visual representations of the spectral data. Enjoy experimenting with sound design using this technique.